Salesforce Lightning Web Components is a new programming model for building Lightning components. Until recent years, web standards only offered a limited foundation for the full stack that developers need to build large-scale web applications. A rendering engine, standard elements, events, and core language, ECMA script 5. The community and software vendors jumped in to fill the gaps with custom frameworks such as React, Angular, and others. Although this community and software vendor efforts, they also came with a number of challenges. Frameworks provided such a high level of abstraction that they feel like different languages. As a result, skills were not transferable, and developers' apps and components written with different frameworks are not interoperable. Fast forward to 5 years from the time of Aura. As you can see, today's web standards include many functionalities that in 2014 were frameworks. Lightning Web Components is a Salesforce implementation of the new breed of lightweight framework built on web standards. On top of the core stack, it provides a layer of specialized Salesforce services, including security with Lightning Locker protection. Lightning Data Services provides declarative access to Salesforce data and metadata, data caching and synchronization. And base Lightning components, a set of over 70 UI components to build custom elements. Web components are based on 4 main specifications. HTML templates with template tags. It's user-defined templates in HTML and rendered only when called upon. Custom elements provides a way to build custom fully featured DOM elements. Shadow DOM provides encapsulation of markup structure and style from other code on the page. And ES models defines the inclusion and reuse of JS documents in a standard-based, modular, and performant way. There are now 2 ways to build Lightning components. Aura components, leveraging its Aura component model, templates, and modular development programming model, and Lightning Web Components, built on top of the web standards. As a large portion of this is now native browser-provided features, the framework is lightweight and delivers exceptional performance. Components can coexist on the same page. Lightning Web Components can be embedded inside Aura components, but not vice versa. They share the same base Lightning components. Base Lightning components were already implemented as Lightning Web Components. They share the same underlying services: Lightning Data Service, User Interface, API, and others. They're able to communicate. Aura and Lightning Web Components can communicate using public API and events. Lightning Web Components benefits over Aura components. They're easy to learn. Lightning Web Components basically take the form through native web standards in the browser. We only need standard JavaScript to develop. Better performance. Without an abstraction layer like Aura or any other frameworks, Lightning Web Components render faster. More standards, less proprietary. Using built-in browser features from Web Component standards results in less customization. The Aura is proprietary in opposite. Common components, service components. We can now write components that have no user interface and can be reused with other components, which are more efficient than static resources. Easier to run for developers. No additional framework is needed to learn, and hence transition for the developers is a lot easier. Better security, better testing, and better browser compatibility. The CSS, script, and DOM isolation are better and has more limited event scope, leading to more consistency. And of course, they are the fastest in the galaxy. It's a lightweight framework built on web standards, and it's faster in loading. Lightning Web Components have a lifecycle managed by the framework. Lifecycle hook is a callback method triggered a specific phase of a component instance lifecycle. The constructor method fires when a component instance is created. Don't add attributes at this phase. The connected callback lifecycle hook fires when a component is inserted into the DOM. The rendered callback is unique to Lightning Web Components. use it to perform logic after a component has finished the rendering phase. The error callback is also unique to Lightning Web Components. Using this hook, an error boundary component captures errors in all the descended components in its tree during one of their lifecycle hooks. The disconnected callback lifecycle hook fires when a component is removed from the DOM. Lightning Web Components supports the same browsers as Lightning Experience. For Internet Explorer 11, Lightning Web Components uses compatibility mode, but performance suffers. Lightning Web Components are supported in many Salesforce experiences and tools. Currently unsupported are the following. To use a Lightning Web Component with this experience and tools, wrap it in Aura component. To experiment with Lightning Web Components, you can use online interactive code editor. Write JavaScript, HTML, and CSS code and preview the output as you develop. Save playground apps and share them developers. Resources. You can use the developer guide link to investigate the subject. I will provide you with a QR code. The Lightning Web Components are open sourced, allowing the community to contribute to the roadmap and to use the same JavaScript framework, whether they are building applications on Salesforce or on any other platform. And now, let me represent you my Lightning Web Component app built for this presentation, the SABERS catalog. The app consists of 4 nested interoperable Lightning Web Components: parent catalog, list, item, and detail. Lightning Web Components and Aura components can coexist and interoperate on a page, and to admins and users, they both appear as Lightning components. Let's dive into the application source code. The essential pieces of Lightning Web Component are HTML, provides the structure for your component with a template tag. JavaScript defines the core business logic and event handling. Configuration file, an XML file that defines the metadata values for the component, including the design configuration for the Lightning App Builder and Community Builder. And CSS provides a look, feel, and animation for your component. The template tag in HTML defines the structure of your component using HTML. The identifiers in curly braces are bound to the properties of the same name in the corresponding JavaScript class. The conditional directives like if true or if false within template determine which elements are rendered. In the JavaScript file, the import statement brings in the core model LWC to bundle core functionality and make it accessible. The export statement defines a class that extends the Lightning element, is a base class for Lightning Web Components. The next component is list. Here we can see, for example, for each directive, it's for rendering a list of items. A key directive is required to assign a unique ID to each item. And when a list changes, the framework uses a key to re-render only the item changed. Lightning Web Components JavaScript uses the following decorators. API marks as a property as a public reactive for use in template or other components. Track marks a property as a private reactive for internal monitoring. A template or function using this property forces a component to render when the property value changes. The wire service is a part of platform. It delivers a stream of data. To use the wire service, import a wire adapter in the JavaScript file. Decorate a property or function with a wire decorator. Here's the item component. Here we notice item click in item.js file. Here we fire the event from cItem and the detail component. Here we can notice showToast event that imported from Lightning platform showToast event and the get record from UI record API. That's all from me. Thank you, and may the Salesforce be with you always.
We can see that 148 people voted. Second place is Ruslan Mullayanov, please welcome.